Hello, and thank you for joining us from wherever you are in the world. My name is Akshat Rathi, and I'm an energy and climate reporter with Bloomberg News and a senior fellow at the Atlantic Council's Global Energy Center. I will be your moderator today. I'm pleased to be joined today by an esteemed panel as we explore new battery advancements in the context of geopolitics, the clean energy transition, and the pandemic. This event was made possible with the collective effort of the Atlantic Council Global Energy Center and Geotech Center. Before we get started, a few housekeeping notes from me. This event is on the record, and we are currently live streaming on Twitter, Facebook, and YouTube. While sharing on social media, please use the hashtag ACEnergy. If you'd like to participate in our conversation, we encourage you to submit your question in the Q&A portal located at the bottom of your Zoom screen at any time during the event, and we'll try to come to that question when appropriate. Only those engaging via Zoom will be able to submit questions. So, what is the frame of our conversation today? Debuting in the 1990 in a Sony camcorder, the lithium ion battery has been on a tear over the last 30 years. From laptops to smartphones, and now from electric cars to even electric planes. So far, the revolution has been powered by small but crucial incremental changes. That's helped cut battery costs by as much as 90% over the last decade. It's not an understatement that batteries will, in part, underpin the clean energy transition. But we now stand at an interesting juncture. This enabling technology needs to get better as it finds greater use in mobility and in smoothing out renewables. We'll need next generation's technologies to get there. But we also have a pandemic and we have an economic recession. How then will we get those technologies? What supply chain constraints will they bring? Which startup founders will become billionaires? What countries will take the lead? Those and many questions we'll get answers for today with our esteemed panel. It's my pleasure to introduce Dr. James Frith, Head of Energy Storage at Bloomberg NEF, Doug Campbell, Chief Executive Officer of Solid Power, Jackie Murray, Deputy Director of Faraday Battery Challenge at Innovate UK, and Vivis Kumar, Principal at Benchmark Mineral Intelligence. We are excited to have them with us today. To start off, I'm going to ask each panelist an opening question. They'll first tell you a little bit about themselves, then answer the question. After that, we'll have a conversation between the panelists before taking questions from the audience. I'll start with James. James, lithium ion batteries are falling in prices and they're expected to continue to fall. Why then are we talking about beyond lithium ion today?
Yeah, perfect. Thanks, Akshat. And I guess a bit of background about myself. So I've worked at Bloomberg NEF for about 3 years, heading up the energy storage team. And in that kind of role and in the team, what we do is we look at kind of lithium-ion battery technology, as well as looking at the supply chain and the value chain. So, what materials are needed, as well as who are the companies that are involved in this. And prior to joining Bloomberg NEF, I was a researcher working on, I guess, what you would call kind of beyond lithium-ion battery technology, as well as doing a little bit of dabbling in lithium-ion. So I think the question, around why are we looking beyond lithium-ion when prices are falling is a really interesting one. And I think, to start with, we should frame kind of what do we mean by beyond lithium-ion? Because we're not necessarily talking about moving away from lithium completely, but we're looking at kind of advancing it. So the lithium-ion battery gets its name because the lithium within it stays in a kind of an ionic form the whole time, so it's charged. So when it's in the cathode, you have the lithium plus, and the electron is kind of it goes into the rest of the cathode structure. In the electrolyte, the lithium is in an ion, and then again in the anode, the lithium, the electron for the lithium is delocalized. So within this whole battery, you have a lithium ion. When we talk about beyond lithium, we're not necessarily talking about moving away from lithium, but we're talking about the next kind of lithium-based technologies that can help increase energy density. And there's a number of different technologies that I think are kind of particularly important there. You have things like improvements in the anode. So as I mentioned today, you mainly use graphite, and in that graphite, the electron is delocalized, your lithium remains a kind of ion within that. But people are looking at moving to silicon and then also moving to lithium metal. And so in those anodes, you no longer have that lithium ion. You have kind of either the lithium metal form or you have the lithium reacting with the silicon. And similarly, kind of the next, I guess, advance beyond that would be solid state electrolytes, which also enable solid state batteries. And they, rather than using the kind of liquid that's used today, they have solid materials where, again, depending on the material you're looking at, you're not necessarily looking at kind of an ionic lithium form. And in cathodes, I guess, are the kind of bit that isn't changing in the same kind of step change that we see for the other materials. So cathodes, for the kind of foreseeable future, will generally stay around those insertion materials that we use today. But there's still a good kind of 25% of energy density that you can, improvements that you can get with those materials. So there's still a way to go. And so to the point on question, why are we looking at these materials and what does it have to do with pricing? Well, one of the key kind of determinants of prices going, for lithium batteries is the raw material costs and the energy density of the kind of material in the cell. So if you have a higher energy density, the throughput of your manufacturing equipment, you have a higher throughput, so more gigawatt hours for that same capex investment. So it helps to bring down prices. And similarly with materials, if you have a higher energy density material, you need less of it to go into the battery, so your prices can come down. So when we talk about beyond lithium and the kind of impact on pricing, we're really talking about improving the energy density with these advances to help kind of push prices down. And there will be other impacting factors on prices as well, such as kind of manufacturing. But I'll leave it there for the moment, and I'm sure we can dive into some of this later.
One very brief follow-up. Are any of the beyond lithium-ion technologies already in application somewhere?
Yeah, so that's a really good question. And I mean, the short answer is yes. So if we look at companies like Bolloré Group's Blue Solutions, they're using lithium metal in their cells today. And similarly, we've seen the kind of slow introduction in some sectors of kind of semi-solid electrolytes. So we've seen the separators that are prevalent in lithium-ion cells today. Some of the early kind of adoption of solid state was impregnating that separator with ceramic. Now that doesn't make it a solid state battery, but it's getting that material into use.
That's great. Thank you. Doug, I'd like to bring you in. You're building a startup that has one of those next generation technologies. The name of your company gives it away. So what have been the biggest difficulties you've faced so far, especially in the last few months with the pandemic? And what do you anticipate as further difficulties coming as we navigate what is going to be a rough economic climate?
Sure. Well, I'll start with some historical perspective in terms of challenges. Anytime you're developing a new battery chemistry, that is hard work. I don't want to trivialize how much effort goes into really developing a chemistry to meet requirements, and that's really essentially been our existence really for the past 6 years. That being said, obviously we've made some considerable advancements, such that we've had strategic partners and investors really sort of get behind us because they're now seeing a very viable pathway to a commercial product. So that's from an overarching context. That's kind of the main challenge that we're addressing as a company. To your point, most recently, obviously, we're here on a Zoom webinar primarily because it's not suitable to meet face to face during this COVID-19 crisis. And so for a company like ourselves, absolutely, this has impacted us. We're located in Colorado. I think, as you know, I was just looking on the news feed this morning. California just reported their highest number of cases during the crisis. So clearly, here in the United States, we're on an uptick, and of course, worldwide, we're also on an uptick, and that's something that impacts really every company, ourselves included. Here in Colorado, our governor had some fairly strict controls in place to try to reduce rates of infection, and this was implemented in late March. And so for a period of about 6 weeks, I would say we had to operate on what I refer to as a skeleton crew. pretty small number of staff, on the order of no more than 7 to 8, which is, just about 10% of our total head count. So that was very, very challenging because, again, that came on the heels of us having our production line just operational. That being said, I was really impressed at how we were able to maintain focus despite the limited number of hands on site, such that we came out of our quote unquote lockdown the first week of May, and we were shipping cells the second week of May to our partners. So that's by and large, we've sort of weathered it well. We still, even today, are on a reduced staff, but certainly beyond the skeleton crew. And then, of course, moving forward, obviously, the situation has really rocked the equity markets. And so anyone, a battery company included, has to admit that raising capital moving forward is going to be a challenge. One of the things that I found, though, is very, very pleasantly surprised is that our state transportation markets, yes, their balance sheets are getting hammered, but by and large, they have not wavered on their vision of vehicle electrification and the need for advanced battery technology. So our stakeholders are still engaging, again, despite the financial constraints. And so we're preparing for, eventually we'll need to raise some additional capital. Clearly, the COVID situation is going to make that more challenging. But I think the space that we're in, the momentum towards vehicle electrification, I mean, that it is too, you cannot overcome it. It's going to happen. And I'm pleasantly surprised that everyone's responding very positively.
That's great. A colleague of mine, David Stringer, and I were working on a story which was published last week. We've been working on it for a few weeks, 6 weeks. And every week between mid-May and towards the end of June, we had to update our story because some of the other battery news was coming through. And the most recent one was where Volkswagen invested $200 million or up to $200 million in
Right.
QuantumScape. So I think you're right in that, at least from the major manufacturers, the trend is quite clear. Thank you. Jackie, I'd like to bring you in. This, as you know, is a key time for governments. But even before pandemic hit, governments could do a lot to spur battery innovation. How is Faraday Battery Challenge addressing this problem, and what have your plans changed in the face of the pandemic at all?
So if I give myself a bit of an intro to the listeners. So I'm Jackie Murray. I'm Deputy Director of the Faraday Battery Challenge. And that's a mission really in the UK to get us to being world-class in battery technology. For those listening, it sponsors research. It sponsors then translational collaborative R&D in the mid-TRL levels, technology readiness levels. And also this year we'll see the opening of our £108 million, 200,000 square foot prototyping and scale-up facility, which will run at gigafactory rates. So that's a little bit about what we're doing, because that might help if you haven't heard of the Faraday Battery Challenge before. What are we doing? So I think if we step back for a moment, governments pre-COVID, we could see a couple of trends, right? We could see batteries in volume automotive being a big immediate short-term win, because you need to be designing full electric now to hit the CO2 emissions that are coming in 2030, 2035 in Europe and other parts of the world, California and elsewhere. So what we know is the car companies were looking to shift. And what we also noticed was a global trend of battery manufacturers to move closer to those car companies. And we were seeing that in Europe, and you were seeing that in the UK. And in 2017, the Faraday Battery Challenge was the UK government's response to that. And that was really around the UK research and innovation community really looking at how they could create world-class science, sort of superpower here, if want of a better word, by joining up all our universities and all our researchers and getting them to work together, and getting them to work together with industry. So really smoothing those interfaces between academia, the funders, all the way through to actually commercialization. And then looking at how we took through the Valley of Death and the TRLs, but also gave this opportunity. And as a manufacturing engineer, it's the one I love, where you can actually run prototype batteries at full scale, because just from experience. At that rate, that's where it's all going to go wrong. But it's also where you're going to learn the most. And manufacturing IP is incredibly valuable. So we kind of knew that this was happening, and so governments were looking all around the world, I guess, to work out what they were going to do. I think in the middle of COVID, we've seen impacts. We've seen impacts in cash flow shocks, and lots of things that everybody and Doug beautifully sort of described. It's hard to keep going when you're in lockdown and you're isolating. But actually, we've seen a huge appetite and a huge resolve to keep it going. And we've sort of seen forecasts of full electrics sort of actually get higher, and that batteries are going to get higher. And I looked up before I came on today, just have a quick look, and I saw that the Tesla Model 3 was the biggest selling car in the UK in May. And that's, against all the internal combustion engines. That's outstanding. We see those full electrics, those registrations up by 131% this year still, and that's compares with sort of drops of 55% in petrol and 66% in diesel. So you can see the impact of COVID. So what we know there's cash flow issues for car companies because of those shocks, because of that. But we can also see that actually perhaps we're in the middle of one of the biggest air quality global exercises ever. People can see the difference in air quality, have been able to taste the difference in air quality, and we're already seeing data coming through, and there's real appetite for the public to come out in a different place. So what that means for governments is it's tricky, and I'm going to sort of give it back to you. But it's tricky because we're also seeing this trend that COVID requires much more government intervention. So what can government do? And the answer really is to understand the space, understand how they can invest money that keeps those companies going into the right things. So I think those governments, those parts of the world where they've already started to take these steps, where they understand Doug's point about the nature of battery development, that it's very bespoke and it's very complex. The more you understand it, the better those interventions are going to be.
That's great. And are you hearing? I know you're only you're far away from the government, but are you hearing any news about whether the UK government is looking to put some stimulus money toward electric cars, electric car batteries? There was a recent announcement that probably would be worth telling people about.
I'd love to give you an announcement. I'd love to tell you lots of things. I can tell you that my team and I are working very hard at the moment, but I can't actually give you any confirmation right now. I think you have seen, though, some very significant sort of announcements in the UK around sort of net zero and green infrastructure going in. So it's not just, I think, solely around batteries for propulsion. It is actually that wider piece, that transformational change that's really important. We're consulting currently on actually banning internal combustion engines, potentially including hybrids by 2035 in the UK. So I think politically you can see the direction. I can't give you any hints on what they might look like as much as I'd love.
All right. Great. Well, I'm going to bring Vivas in. One thing that, having covered batteries for a while, always keeps coming up is, will we run out of metals to make batteries? So let's lay that to rest. Is that going to happen? And if not, what sort of challenges should we be expecting?
Yeah, thanks for the hard question, Akshat. And first, I just want to start by thanking you for inviting me to this panel. And for all of you out there, thank you for tuning in. So just a quick background on who I am before I answer the question. Right now, I'm a principal with Benchmark Minerals Intelligence, which is a market research and consultancy focused on the lithium-ion battery supply chain. Previously, I was one of the senior managers for the battery supply chain at Tesla, based in California. If you want to follow me, just Google my name and you can catch me on LinkedIn or Twitter. Now, to the question that you asked about, are we running out of battery metals? The answer is yes, we're running out of some battery metals. So lithium ion batteries have multiple different chemistries, NCA, NCM, and they all use different types of materials like nickel, cobalt, aluminum, manganese, etc. To overcome some of the challenges that we've seen in specialty chemicals like nickel and cobalt, both from a supply standpoint and from the well-publicized ethics standpoint regarding cobalt from the DRC, we've seen companies shift towards chemistries that use less of these materials, even shifting as far as using LFP batteries, which are lithium iron phosphate batteries, because iron and phosphate are plentifully available and are industries that have been commoditized over multiple decades of development. However, the one element that we can't walk away from to make lithium ion batteries, it's in the name. We can't walk away from lithium. And unfortunately, given the current pace of supply development, in the face of demand development, we are expecting shortages to happen by the mid-2020s for the specialty lithium chemicals. Now let's kind of deconstruct what I said over there, specialty lithium chemicals. What matters is not the production of lithium raw materials. What matters is the production of a high quality, high purity chemical that can be used in battery manufacturing. The number of companies that can produce at a large scale these high purity, high volumes is very small. And they are constantly capital constrained, as is the reality in much of the mining and chemicals industries. So once again, the short answer to the question of are we going to run out of battery metals? It's let's focus on lithium. And given current trends, the answer is yes, we are going to run out of lithium if the demand keeps up, as it has been, exponentially growing over the last 5 to 6 years. Now, to the question of what can be done about it. So the first, and I really appreciate everything that Jackie said about the role of government, because I also just can't emphasize enough how important the role of government is in solving this problem. The battery supply chain is complicated, but if we were to simplify it, it would be, for example, for lithium, you go through a mining phase, a chemicals phase, it gets put into a cathode, and then it gets put into a battery cell before it goes into a vehicle or an energy storage product. The earlier stages of that supply chain, mining and chemicals, are very capital intensive and take anywhere from 7 years to 25 years to develop. That kind of long scale, large capital investment cannot just be done by companies. They're usually done in tandem with the governments and the jurisdictions in which they work. So those countries that are well endowed with the natural resources that are necessary for battery manufacturing are well placed to spur more investment in the supply chain, for them to create high-paying jobs in the specialty chemicals sector, as well as a high revenue multiple for their own taxes, but also to ensure that we overcome this challenge of the battery metal shortage that's impending.
As we talk, there is a Senate hearing happening about this very question, whether battery metals, whether governments need to A, recognize the importance of battery metals, and B, what to do about it. What have you heard or seen in the US specifically tied to the metal supply chain and some of the solutions you were talking about? Are they being implemented or even considered?
Yeah, our managing director, Simon, actually was part of the Senate hearing today, so thanks for bringing that up. The way that I would characterize US government action, so I have personally been in conversation with various parts of the US Senate, White House, Department of Defense, USGS for about 4.5 years now. 4.5 years ago, the conversation was all about educating them on why lithium-ion batteries are important. Now we are well beyond that. Beyond the Tesla Gigafactory investment, we've of course seen the GM and LG Chem investment jointly in Ohio, but of course we're seeing 9 different megafactories, which are lithium-ion battery factories with over 1 gigawatt hour per year of production being built in the USA. So at the government level in the US, there is a recognition of the importance of this sector for the future of automotive and the future of energy storage and grid scale utilities in general. We are now past that step of the supply chain, and we're advocating for increased investment and industrial policy towards building out the supply chain upstream of battery cells. Industrial policy is a bit of a dirty word in US politics, because generally speaking, US political stances with a subject like building complex supply chains has been create efficient capital markets and create a policy environment in which entrepreneurs and companies can succeed without government intervention. But now there's a recognition that that approach has not yielded the fruitful results that the US would like. And similar to how the US was very dependent on foreign sources for energy throughout the 1900s, we are now once again starting to become dependent on foreign sources, friendly or otherwise, for the materials to build the battery supply chain. So the whole point of the Senate hearing today was to confirm that the senators get that message. And from the tenor of the conversation, it seemed like they certainly do get that. What's important now is jumping forward into action.
That's great. Well, so we've touched upon a wide variety of uh, subjects within this little battery space. And I'm going to try and ask some follow-up questions and try and make this a conversation. There are a lot of questions coming from the audience, so I'm going to throw some of that in as well if it perfectly appropriately fits there. Vivis, just to finish off on the point that you raised about the senators getting the point that the metal supply chain is very important. Is it your sense that this sort of support is going to be bipartisan? In the US, we have a very polarized politics, especially on the environment. Is that also the case on metals?
This is a question of political messaging. What we found is when we try to message this as part of the clean energy, climate change, global warming related movement, those arguments fall flat because those words are generally construed as being partisan language. But when we couch it in terms of the job creation and the industry creation that can happen in the US, every politician wants jobs to be created in their jurisdiction. And going back to the argument that I made that it's not about the mining resources running out, right? There's tons of lithium in the world. Mining isn't the problem. It's the specialty chemical to produce the battery grade materials that we need. Those are high paying, high skilled jobs with large value multipliers in economic development. That is an argument that passes muster regardless of if you're an independent, a Democrat, or a Republican in the US.
Got it. Doug, one of the things that if you're able to get to solid state, one of the things it will enable is the use of lithium metal. Vivis has talked about lithium chemicals that will be needed in current lithium ion technology and future, but lithium metal is a very special case. Could you tell us a little bit about why the metal itself is special and how its manufacturing and the cost of its manufacturing will play into the solid state space? You're muted.
Yeah, I'm sure everyone does that 10 times a day in this day and age. Yeah, lithium metal. So as I like to state, solid state rather than a technology is really a platform, and because you care more about what it enables. I guess solid state generically, one of the key things that would enable was it certainly improved safety, but the other one is improved energy. Now it doesn't just enable improved energy just because you're solid state. It does so through the use of much higher capacity electrochemistries that perhaps are not viable in a traditional liquid system. The most notable one is metallic lithium. Just a simple kind of back of the envelope calculation, obviously dependent upon cell design, but if you were to take a notional cell, replace the graphite anode with a lithium metal, you're going to see anywhere between about 50 to 100% improvement in the energy, both on a per unit mass, per unit volume basis. So obviously, that's a very, very strong value proposition. But to your point, lithium metal today as an anode product for use in a rechargeable cell is not a commodity grade product. It certainly is in primaries. You can go today and purchase a primary cell with a lithium metal, but not in a rechargeable. And why is that? Because it's a different form factor. The lithium metal anode needs to be quite a bit thinner. than what you see in a primary, and that is essentially analogous to product cost. Today, there really, by and large, there are two sort of quote unquote mainstream lithium metal anode products. We call one a freestanding foil product, and then the other being a deposited product. Freestanding foil is typically you'll start with a lithium ingot. You'll do extrusion to the limit that you can do in terms of thickness, and then there's some post processing to further reduce that thickness, and that adds cost. And right now that is still a development material. Similarly, on the deposition side, you're talking about depositing via techniques such as vacuum deposition, thin amounts of lithium onto a substrate such as a copper, which would be your current collector. Similarly, that is not a commodity grade product today. That is still a developmental product. So one of the things that Solid Power is doing is working very, very closely, because we're not a manufacturer of lithium metal anodes and don't have a plan to be so. But we work with very well-established players in the field to basically mature their product, give them material, give them performance specifications, show how it performs in full-scale cells, and then ultimately work with them to understand how the cost of this particular product can come down. And I will say that we are increasingly confident that provided the market demand is there, the cost of those anode products will come down.
Got it. And Jackie, just to follow up on what Doug said, which is startups are looking at this sort of model where they develop the technology and then work with manufacturing partners to bring their technology into the commercial space. Has that been the sense that you've had from the startups you've interacted with through the Faraday Battery Challenge?
I think that's absolutely right. I think maybe it's a 21st century issue. The complexity of what you're trying to do is so great that actually working with people actually making the products is really important. And I think for battery chemistry, it's because actually almost every application could have a bespoke chemistry for it. One of the things we're trying to do, so you can tell I'm an engineer, so we try and own this problem, right? It's flipping complicated. That's a bit of a British thing coming out. So actually, if we look at that and say, okay, how can we understand all the different applications, their duty cycles, and actually help those like Doug or others in SMEs understand how their products could have one, maybe two, maybe three, maybe more applications that are cross-sector, because you're trying to navigate such a complex space to get to market here. So yes, we definitely see that. I was speaking to one yesterday who they're specialist batteries in military applications, and through the Faraday Battery Challenge, they've doubled their turnover in 3 years, and they're looking at doubling again in the next. And what's interesting about it was they wanted to diversify, but understanding where you can diversify and how you can de-risk that. And that's what Faraday does. We don't just give them money, we give them matched money. So they have to go and find partners that will actually also put skin in that game. But you then de-risk the higher risk innovation, the ones that leap forward a bit more. So yes, we're definitely seeing that.
Got it. Well, I'm going to start going to audience questions very briefly. Before that, though, I'd like to bring in David Bray, who's the director of the Geotech Center, for a question.
Thank you, and I want to thank all the panelists. This has been a fascinating conversation. We've talked a little bit about the challenges of working across different nations, how the United States is thinking about how to make sure there's not a too heavy a dependency. My question might be, what can nations do to work together both on the technology, but what can we also do to try and think of this as not just a single nation challenge, but what can we do for a whole of Earth or a whole of planet challenge? So I'd be interested in the panelists' thoughts about technology-wise, what can we do to work across different nations on this?
James, do you want to start with maybe a little bit of understanding of the different countries and different regions that are competing?
Yeah, sure. Happy to kind of take this one on. And I think it's good to think about the context, I suppose, of where we've come from. And I guess kind of back to what Vivas was saying around, the US wanting to become energy secure and not rely on other countries, I think over the last kind of 10 years or so, there has built up a bit of a mindset around, it's the rest of the world versus China. China has all this capacity and we want to get some of that. And I think that is beginning to go a little bit, and we are seeing more, I guess, collaboration across countries, but we're still not at that global scale. But if you look to Europe, for example, there's a clear kind of driven or drivers behind European countries working together to try and push forward battery technology, but also to kind of look at other metrics as well. So looking about being the greenest batteries. And so while that's still not quite at the kind of, the whole globe working together, clearly that has a benefit for the whole globe if we're making batteries greener and cleaner. And we would start to see kind of, we'd expect that we'd start to see other countries following that as well and trying to kind of green their supply chains. That being said, I think the notion of kind of everyone working together globally is a great one. I think we're probably still a little way away from that. I think at the moment, most kind of countries and regions are still being quite protective. They're worried about losing manufacturing jobs when we go, as we switch more from internal combustion engines to electric vehicles. And we've seen kind of reports in the past saying, you need less, there are less manufacturing jobs associated with electric vehicles because there are less moving parts. So lots of countries are now looking at, building the battery and getting that supply chain. But that being said, I think there are very few countries where you can have that entire supply chain within, one country. So you will have to work together, and we will see that. And we saw, for example, in Chile, they put out a tender to try and get foreign companies to come into the country and, add value to their lithium. And so there were kind of initial plans around POSCO and Samsung SDI building plants. So that, they kind of fell through, but they're kind of going through that process again. So there definitely is, a movement to kind of, work together to develop the supply chain and kind of bring it to everyone. But we've still got a way to
go. Great, thank you. One question that's come, and this is probably if Vivas or Doug, one of you, from Venkat Viswanathan, who's a professor at Carnegie Mellon University. He says, given the current time, we need more automation in R&D. While that's happening to some extent in manufacturing, why is it limited or non-existent in the R&D space? Doug?
A bit of a tough question. Automation in R&D is I guess, easy to envision in theory, difficult to reduce to practice. For example, there are groups out there, companies that are doing some of their sort of high throughput chemistry development, such as Wildcat in San Diego, and it is a very, very powerful tool. But it does have limited reach. So in other words, you can certainly at a small scale do some automated evaluation of new materials, new additives, so on and so forth. But the challenge of batteries is that some, performance at one scale does not necessarily translate to performance at another scale. And that is because as you scale, processing characteristics of the chemistry become so critical. And that's where it becomes quite difficult to do that in an automated or high throughput manner. So from my perspective, I do see a lot of value in some of these high throughput, combinatorial chemistries, systems that are out there. But you just have to recognize that can only take you to a certain point. And then at some point, there's just no getting around the fact that you need to roll up your sleeve and do the hard work on the scale side of things.
Right. And on automation, maybe James, you can tell us a little bit about how automation has revolutionized battery manufacturing and how has it played in lowering the costs?
Yeah, so automation here is kind of really important, and I'm sure Jackie, as an engineer, can probably add something to this afterwards. But if you look at what we started with lithium batteries in the kind of 90s and the kind of thousands and 2000s, you had a lot of manual processes. You had people there kind of involved in the electrode winding process, kind of taping the end of these electrode rolls together. That obviously kind of limits it. And on top of that, there were more batch processes, more, moving bits of equipment around. At one point, the kind of manufacturing model was you create what are called the jelly rolls, so the cathode, the separator, and the anode. You create them in one factory and you send them to another factory. Now, obviously, there's kind of cost involved with that, the logistics involved, and it's not that efficient. We've now moved to a kind of model where these manufacturing lines are designed so that it's just one continuous process almost. Sometimes you have to take it across the factory floor, but it's all in one building. And it's been done at high speed, at kind of, working in ways that humans just couldn't. And getting that, I think getting that uniformity that is essential. And I think the key bit of automation when it comes to costs here is about increasing that throughput and that uniformity and reducing the scrappage and just making sure that process is as seamless as possible. But Jackie might have something to add on this with the UK BIC about.
I'm going to bring Jackie in, but I wanted to share, I got a chance to go through the CATL manufacturing facility. So CATL is now the world's largest lithium-ion battery manufacturer. And my impression, I mean, you get a tour, and so the tour is clearly meant to impress you. But even with that, the number of robots outnumbered the number of humans on the factory floor, which was surprising and interesting to watch. Jackie, thoughts on this?
Yeah, so I'm going to chuckle. So you probably all thought I was a steel worker when I dialed in. It's a continuous process, and it's the control level is atomic almost in quality. So what's difficult, and I guess this gets to the heart of the question, but also the heart of why the hell we're building such a big investment in a prototyping and scale-up facility. If you interrupt that line that's in a stable situation and is churning out all your millions of batteries that are currently making you money, you lose yield massively. And so the UK Battery Industrialisation Centre, the chief executive, or the MD I should call him, is Jeff Pratt, and he used to run the battery plant for Nissan, for the Nissan Leaf in Sunderland, right? And he will tell you the pain. And you're talking, because the cost of the materials and the cost of the battery is so much greater as the cost of the vehicle. Actually, when you start losing high levels of yield, you start invalidating the vehicle, right? Full stop. So it's really difficult. And so the question is, how do you do it? And if all the manufacturing IP, if all the manufacturing know-how and the equipment manufacturers and everyone else is in the Far East, actually the OEMs can't really work with that. And they need to work with it, and they need to work with it for lots of reasons, because everything we're touching on is so important. So the sustainability, the traceability, the efficiency of the EVs as they come through from cradle to cradle, right? The recycling of them, the yields, the bringing the cost down, all this has to pull together. And that's really what the UK BIC is about, is, as I said, it's where things go wrong and it's where you can put them right. I think Doug was talking about different, you can get something in a button battery format and you try it at scale and it doesn't work, right? So there's an element here that we have to sort of enable companies to do this. And in Europe, actually, UK BIC will be the first one like that. But you are seeing companies like BMW and others starting to invest in these centres, because to muck about and to train your staff, even if there's not very many of them, actually is really important. Get your machine settings right and your engineering absolutely bang on is critical. And as an ex-steelworker, you could walk along a steelworks today and not see very many people.
Right. Well, thanks for that. Vivis, there are a number of questions that have come in that are tied directly to mining. So I'm going to do a little bit of a quick fire question round for you. So if you unmute yourself, I'll ask you a question, give me a short answer, and then we move on to another question. So somebody asks, this is actually Tim Jonan. He asks, can you talk a little bit about class 1 nickel shortage? Is this on the horizon, and why?
So I would say, let's differentiate, just for those of you who are wondering, class 1 and class 2 are two different types of quality of nickel. If you could say that, quality is a simplification, but just go with that. Generally speaking, it's considered that class 1 is better suited for battery manufacturing than is class 2. There seems to be a lot of class 1 nickel out there, but at the same time, the question is not the primary resource. The question is the specialty chemical used for battery manufacturing, and that remains the bottleneck there as well. However, unlike lithium, you can switch away from chemistries that use nickel to alleviate this problem.
Right. Another one is deep ocean mining or seabed mining has been floated as an idea for bringing some
No
of the
pun
battery
intended.
metal. Do you think it has a future?
Deep sea mining, well, the arc of technology always bends towards, science fiction coming to reality. So I'm never going to say that this isn't going to happen. And it's just a question of at what point and at what scale and at what operating cost it happens. To be frank, given the limited knowledge that I have on seabed mining today, the operating cost is so massive that it does not make sense today. But one day, if the prices spike so much that there is a significant contribution margin to be gained and to build a business around it, then yes, sure. I am also following deep green pretty closely.
Great. This is another pretty cool question. If critical minerals are abundant, why is the US and other Western countries holding back on developing the mining process and the manufacturing process and letting us be dependent on China and East Asia in general?
So, two-part answer to this. First is, even though critical minerals are abundant in the world, the question is, at what cost can you extract and refine those materials? The resources that are in Western countries, generally speaking, are at a higher operating cost of production than those that are in non-Western countries. It's an overt simplification, but if you email me or send me a ping, I can give actual numbers to back up that statement for lithium or nickel, etc. Now, the question of why is the U.S. dependent on China? Once again, this is where there's a difference between the mining asset and the refining asset. The mine is where the mine is. You can't move a mine, but you can build a refining asset to take that mined material and make it into a specialty chemical wherever in the world you want. China has done a very effective job. China as a country and the companies that operate within China have done a very effective job of building this refining capacity. For example, 75 to 80% of the world's primary cobalt material comes from the Democratic Republic of Congo. But something like 60% of the chemicals come from China. There are similar statistics for lithium, for nickel, and for graphite.
Got it. Same with Doug. If you unmute yourself, I'm going to ask you a bunch of rapid fire questions.
Sure.
What is the stage of commercialization for solid state? When do you expect the first solid state battery to be in a car, whether it's yours or not?
Well, bear in mind, that obviously I'm privy to what Solid Power is doing, and I get a little bit of insight into what others are doing. I recognize that there's some things that I'm not privy to going on behind closed doors. So just there's my fine print. I would say probably no sooner than the middle part of this decade. I know there's been a lot of groups that have claimed they'll have it in a vehicle, next year or the year after that. And that might indeed be the case. And in fact, we're targeting that as well. But that would be really a demonstration vehicle. So I'm interpreting your question as mass production, consumer go down and purchase an electric vehicle with a solid state. And that puts aside, for example, I mean, you can, I don't know if you can purchase it, but Bolloré does have solid state batteries with lithium metal anodes in vehicles today, but they're very limited use, and that's because some of the challenges around there. So I mean more of a mainstream consumer-oriented EV mid part of the decade.
Another one is, and this I found as a reporter writing about batteries, there's a lot of secrecy in the industry.
Yeah.
The question here specifically from Sanan is, there is no information about QuantumScape. How have they raised $200 million from Volkswagen? What is the reason for the secrecy, and what do you think makes a battery company special and attract the kind of investments? And you've attracted a lot of investment too. So,
yeah. Well, let me first say that so I don't come out of the battery industry. I've been in the battery industry for 10 years, but I'm actually an aerospace engineer by training. And I'll be perfectly honest, when I got into this industry, I was baffled by the secrecy. It never really made sense to me. And it's something that I personally have never subscribed to. At the end of the day, we need to be a responsible company. I'm not going to give away our trade secrets or the various secrets that we're doing. But I do view a bit of responsibility in terms of disseminating responsibly information within the community and industry. And even to this day, it continues to be a head scratcher to me why this industry is so secretive. But you're absolutely right; it is incredibly secretive. In terms of QuantumScape, I have no particular insight into what they're doing and what is so attractive. I might answer that question just by simply saying, ask Volkswagen.
Wonderful. All right, I'm going to try and do this with Jackie as well. So Jackie, if you unmute yourself, a question about the EU and the UK. Does the EU's strategy on pushing for hydrogen make sense? There is no stimulus program yet from the UK, but do you see the push towards hydrogen a good one, or will it take away from batteries?
So because I'm in something called the Faraday Battery Challenge, people always assume we're obsessed with batteries at all other costs. The reality is, and we're very clear actually as a team, that we're here to try and save the planet, not create a battery industry for the sake of one, right? What we see in volume automotive, and I think the press will bear this out, is, batteries, they're going to be here, and the investments being made by those big volume OEMs into batteries is huge. So fuel cells will come. I know they will come. For volume automotive, they then have to be that much cheaper than the battery solutions, that it can overcome the sort of investment costs of converting to hydrogen. And actually, we know that they can be more complex systems in a volume automotive situation, and we can see that actually that getting scale up to reduce costs is tricky. However, there are the world of batteries is so cross-sectorial now. So where we saw in 2017 the automotive being the first movers, we see aero, we see marine, we see static storage, we see rail, we see off-highway, we see people talking about agricultural vehicles, and moving those very, very heavy loads with huge power in difficult situations, for example, buses, lorries, HGVs. You've got to think that there's fuel cell solutions for that. And actually, personally speaking, being obsessed with batteries, all fuel cells need battery tech too. So all of that sort of works neatly together. And we have to, I think as Doug said, we have to do some work to really understand this space. There's a huge race on, and I think people are fighting each other to win. And it's like, no, guys, it's too complicated, right? You might win today, but you're going to lose tomorrow. So actually, you have to start joining up some of that. And it's very lovely being an engineer at times, because we've done things like 3 codes of practice around the manufacturing of batteries from a health, safety, and environmental point of view, working with engineers to work out actually how do you make that manufacturing at cell level, at pack level, at vehicle level just safer. And better for the environment and lower impact. So some really good stuff going on.
Right. And one other question about Brexit and how that might affect the landscape for batteries both in the UK and the EU.
So, so the answer to that from a UK perspective is that if I then go back to my automotive and put that hat on, 80% of the UK automotive production, whether that's engines, because actually we produce more engines than we do cars. Propulsion is our, I guess, USP as a nation. For all of you into motorsports, you might know that. We export so many, 80%, right? So whatever happens in those major markets, and the EU is obviously a major market for those cars and those engines, and therefore battery propulsion as well. We need to stay in line. So I won't be able to, we won't be able to export batteries to Europe that don't have the required environmental credentials or the battery passport or whatever else it is under the eco design or the batteries directive for recycling and end of life. We'll have to hit all those. So what it does is it means we keep a lot of the same fixed requirements, and we have to get better at working with and finding new ways to work with our partners in Europe.
Got it. And James, we are going to be very close to time. So again, a couple of questions, very short. What exactly can you do to make batteries greener?
Yeah, so that's an interesting one. I mean, they use a lot of energy in the actual production of them. So one of the easiest ways to make them greener is to manufacture them on grids that have low CO2 emissions, or use renewable energy through kind of PPAs or on-sited renewables to reduce those emissions. There are still large amounts of emissions in mining, and that's something that still needs to be kind of overcome.
One other question on electrolyte degradation. So somebody's asked that we know that degradation of the electrolyte, the thing that transfers charge between the two electrodes, is a key problem. What do you think solid state is an answer to try and solve that as a problem, or are there solutions that you can apply to liquid electrolytes to make them degrade less?
Yeah,
so there's certainly.
Oh, sorry. James, do you want to take that one? Sorry.
Oh, you go for it, Doug.
No, that's absolutely a correct statement regarding electrolytes in a traditional liquid electrolyte cell. One of the exciting things that we've demonstrated is that solid state appears to, and I say appear because we're collecting data only over a couple of months now. It needs to extend, to a year plus, but we're demonstrating that the calendar life across a fairly broad temperature range, as high as 70 degrees Celsius of solid state, is actually appears quite significant and quite a bit more superior to lithium ion. So things like irreversible capacity loss due to storage at full voltage at higher temperatures is largely eliminated. And that's really exciting because that can potentially lead to eliminating any need for pack cooling. Because it doesn't degrade your life. So that's, again, one of the nice things that we've started to observe that solid state also brings to the table, because most folks tend to focus on safety and energy, but there's certainly some other ancillary benefits.
Got it. All right. We still have questions that have not been answered, but we are coming very, very close to the end. So I am going to draw this to a close. Thank you, everybody, for joining us. Thank you to our panelists for sharing their perspective. I'd also like to thank Zenab Vironen, Roger Morales, David Yellen, Zach Strauss, and the AC Geotech team. If you'd like to rewatch today's event or share the stream with your colleague, you can find a recording on the Atlantic's website or its YouTube channel. For more from the Global Energy Center, join us tomorrow, 25th June, that is, 12:30 p.m. Eastern Time, for a conversation with Neste's Prateek Chandok on the energy source innovation stream, looking at sustainable aviation fuel. Until next time, thank you, everybody.